Let's talk in a little bit of detail about the energetics of forming ionic bonds. And we're going to use sodium chloride as our example. And basically, chemical bonds will form if you produce a more stable, meaning lower energy system by making that bond. So we're going to talk about sodium chloride. So sodium atom has some size, we talked about, and chlorine has some size, which is smaller because it's in the same period as sodium, but further to the right. All right, so if we want to form sodium chloride, we first need sodium ion, which is smaller, sodium plus, smaller than sodium, and we need to form chloride ion, which is larger than chlorine. And the energetics of turning sodium into sodium plus is known as the ionization energy. And for sodium, that is 496 kilojoules per mole. All right, and the process of turning chlorine into chloride ion is the electron affinity. You had to add an electron. And that energy for chlorine is a negative 349 kilojoules per mole. Okay, so taking an electron off sodium is something that requires energy. It takes energy to pull it off, whereas adding an electron to chlorine actually gives back energy. It's negative energy. All right, and then once we have sodium plus and Cl minus, they can then be attracted to one another because it's a positive and a negative charge, and they form sodium chloride. And the energy of doing that last process is highly attractive, so it's very negative, and the value is negative 787 kilojoules per mole, and that is known as the lattice energy, although actually it's the negative of the lattice energy. So we'll say negative lattice energy. Okay, so the opposite process, actually going from sodium chloride to the ions, is the positive lattice energy, a minor distinction. All right, so now let's talk about the energetics by looking at it on an energy level diagram. So we'll make energy go up. And we'll do it in units of kilojoules per mole. And we will start with our sodium and our chlorine at some energy. We're just going to arbitrarily pick a spot. It's arbitrary. All right, so that's our start. That's where we have sodium. Whoops, that's not going to work. We have sodium and we have chlorine. All right, so as you'll notice from up above, in order to make sodium into sodium ion, that's a positive energy, 496 kilojoules. So we're going to then go up in energy, 496 kilojoules per mole. I didn't need to write all that in there, but and then the next thing we're going to do is look at the chlorine, which is negative 349. So we're going to then go down in energy 349. All right, so that gives us at that energy, we now have sodium ion and chloride ion, and we need to form sodium chloride, and that's a big decrease in energy. So we go down 787, and we end at sodium chloride. All right, and the start place was sodium and chlorine separate atoms. Okay, so we can also talk about the net process, but we're going to save that for a little later. Well, I can list it for you. Okay, so if you want to know going straight from sodium and chlorine to sodium chloride, you can figure that out by with these other numbers. It would be negative 640 kilojoules. All right, but there's a problem with this description, and that is that when we find sodium naturally occurring. It's not a sodium atom singly. It's in a metal. And when we find chlorine, naturally, it's in a diatomic gas. Okay, so we actually, to do this process right, we need to start from materials as we find them naturally and create sodium and chlorine atoms. So let's add that step, those two steps. Okay, so first we need sodium chloride as isolated atoms. In their natural state, sodium is bonded into a metallic network. So we're going to turn that into a single sodium atom, pull a single one out, and that energy, to do that, to pull it out, is 107 kilojoules per mole, and that is known as sublimation. There are some other names for it that we could use. We're going to use sublimation. And chlorine comes as a diatomic gas. Okay, so it looks like chlorine bonded to chlorine. And so in order to turn that into a single chlorine atom, well, let's start with two chlorine atoms, because we have two here. We have to give it some energy to pull that bond apart, and that is known as the bond energy. And that value for chlorine is 244 kilojoules per mole. All right, we can call that the BE, bond energy. All right, but that does produce two chlorine atoms, and we only want one for every sodium we have. So we're actually only interested in half of that energy. So we're going to take half of it, and so we're going to have 1/2 the bond energy, which is half of 244, 122 kilojoules per mole is all we care about. All right, so now let's use those values and redraw our energy diagram. Okay, so energy is going to be going up this way. I'll just put E. And you may remember we started at some value where we had sodium and we had chlorine. Those are separate. Okay, I'll put a comma. That doesn't work. Can't do it. They're separate. I need to rewrite that, so we're going to get rid of that. Well, I can do a comma. Okay. Then we go up 496, and we go down 349. Sorry about that, not very straight. Go down 349, and that was, and then I'll add in the negative 787. Okay, this is what we had before, and we ended with sodium chloride. Not going well here. Sodium chloride. Okay. But what we need to add in then are the other two steps to form sodium atom and chlorine atom. So we'll add the step which is 122 kilojoules. That was, if we go up, that was this one here. Whoops, lost it. The bond energy, half the bond energy. And then the other one is 107 kilojoules for the sodium, forming the sodium. And those are both positive, so they're up arrows. So we'll have another level, and we'll have 107. So that's starting from sodium metal and chlorine gas, actually a half of a chlorine gas. All right, so now our net, and I have gotten a little off scale here, the net going directly from the start to the finish would be a negative 411. Then we can rewrite that as a chemical equation and say sodium solid plus 1/2 chlorine gas produces sodium chloride, and the energy is of that process is negative 411 kilojoules per mole of substance. All right, so this whole thing we just did is a cycle, and it is known as the Born-Haber Cycle, where we can put everything on one graph in a circle, and you actually could solve for any one of these pieces, any one of these arrows, if you knew all the rest of them. And so there may be some problems to practice doing that.